STEM heads! Today, we're visiting Davis Technical College to explore their 4 incredible manufacturing programs: welding, machining, composites, and automation and controls. Let's meet the instructors and students to see what it's really like to learn these skills. Hey Ben.
Hey, good to meet you.
Owen. Mason.
Good to meet you.
So tell me about some of these sculptures you have here.
Yeah, so these sculptures are pretty cool. They represent a lot of hours that our students have spent learning how to weld and then taking their craft up to the next level. Both of these 2 sculptures competed in Skills USA. It's kind of like Olympics, but for the trades.
So why did you guys decide to become welders?
For me, it was really just, I started in high school. I just kind of fell in love with it after I started, so.
Nice.
For me, it was about the job opportunities.
Honestly, I didn't really like school very much. I got caught looking out the window when I should have been paying attention. My teacher always told me I'd never make a living looking out the window, and she was wrong. Here I am.
I love that. So how much do welders usually make?
I would be absolutely amazed if you got out of this program and were somehow making less than $20 an hour. I think most students on average are probably getting more towards that $25 an hour range.
Wow. Nice to meet you. I'm Liam.
I'm Coleman.
I take it that you're gonna show us some demos here?
Yeah, we've got some safety equipment and some stuff set up if you want to come in here, and then we'll get it going.
That's great. Let's go check it out.
What we have here is stainless steel and then some stainless steel filler rods. This is our TIG torch. Gas comes out of this nozzle that shields the arc. We'll take like 2 pieces and you can set them up. So we'll set that up like that. All right, we've got our torch here and this is our pedal. And that's going to control how much heat it's going to put into our material. Set that up, and then we're going to tack these together before we weld it. So you have one hand as your filler hand, and one hand as your TIG hand, and you're just going to run it by this way and add filler as you go. So when we finish our weld, we're going to want to hold this here so we can keep that gas shield over it for just a moment, and then we're good. With stainless, what you're looking for is that golden brown color. That means your heat was just right.
Nice.
And the purple means it got a little bit hot.
I take it it's similar to soldering?
Yeah, very similar to soldering.
I used to think welding was just joining 2 pieces of metal together, but it's actually a lot more complicated. Here in the welding program, students learn multiple types of welding and even fabrication, which means designing and building real structures and products. And with the demand for skilled welders in industries like construction, manufacturing, and aerospace, these skills can lead to some great careers. Now, it's time to move to the next program at Davis Tech, machining. What careers could someone with a machining certificate go into?
Great question. So we've got some examples here of fields like aerospace, we've got firearms, medical, automotive.
This is great, but tell me some of the students you have here.
Yeah, absolutely. There's Hunter, Ray,
Oh, nice to meet you. Nice to meet you.
Some of our
So why did you guys decide machining?
I chose machining because there are thousands of jobs here in Utah and all over the country, and I could go in the military.
I just chose it because I'm super interested in firearms. Knew I wanted to do something in there.
My brother did the diesel mechanic program.
Oh, that's cool.
And my parents said, oh yeah, that's really cool. He's making a lot of money now. I didn't want to do diesel tech, so I was torn between either the engineering design one or CNC machining. And I literally flipped a coin, but now I'm here and I love it. So
Wow. Gosh, there's so many machines here. Can you guys explain what some of them do?
this one is the VF3. This one takes blocks of metal and end mills. They spin really, really fast, and then they cut through metal.
And this here is the Mazak lathe. This thing spins up to 2,500 RPM. Right here, you get the program, everything. And you could make these little intricate parts here.
I can tell this makes a lot of different stuff.
Oh yeah, it does.
So what does CNC stand for?
It's computer numeric control. The machine follows a set of instructions based on numbers and coordinates.
So would you say it's like a GPS but for machines?
Yes.
And how does the programs of the machines work?
Well, it runs off of a type of code called G-code, a series of letters and numbers all strung together in a certain pattern, and it all is generated from a CAD software.
Another thing about G-code, it's like Python programming. Once you understand the programming aspect of it, you could then start programming different functions and different variables. These things could be made at like 10 times the efficiency if you had automation with G-code.
It almost doesn't even look like it's spinning fast.
right? Spinning at 5,000 RPM right now. Machine is going through and reading that different G-code to do exactly what it says. Like Braden said, using a GPS coordinates to tell the machine what to do.
So what is this machine doing right here?
Yeah, so this is the Equator by Renishaw. So you see that little red dot on there is a little ruby that it uses to measure every feature on that part.
In this program, I learned that machining is all about precision. Using machines like CNC mills and lathes, students can turn blocks of metal into incredibly detailed parts used in airplanes and medical devices and manufacturing equipment. It's amazing how a computer and a cutting tool can transform raw material into something useful. The next program we are going to visit is the composites program. Wait, what even are composites? Hey, I'm Liam.
Hi, Liam, I'm Carter.
Nice to meet you.
It's nice to meet you.
First off, what is a composite?
Composites start out as a fabric, most of the time fiber reinforced fabric. So if you feel that, it's flexible like any other textile material. But once you introduce a matrix like a resin, it becomes a rigid structure.
What industries typically use composites?
Pretty much any industry that wants things to be lighter, stronger, faster. From the deep reaches of space to the depths of the ocean, you're going to find composite materials.
Why is it more beneficial than plastics or metals?
So traditional plastics and metals are often going to be heavier than fiber reinforced plastics because the fibers kind of provide structure without the added weight. And I would want you to imagine how heavy this would be if it was made out of steel. Yeah, it's a lot lighter.
I bet this can get really creative. I mean, I saw the Captain America shield over there.
There's a Captain America shield. There's a lot of personal projects that people put a lot of time and effort into.
And I kind of gotta check this out.
Yeah.
Looks very cool. Hey, I'm Liam.
Nice to meet you, Liam. I'm Ivan.
So I take it you were in 3 programs here?
Yep, I was in this one, composite technology, as well as automation robotics and CNC machining. I started with those because I wanted to understand how things are made and fabricated, and then right now I'm at Utah State studying to be a mechanical engineer. So I'm hoping with the knowledge I gained here on the manufacturing, I can take that and be able to design and build better stuff in the future.
Oh, so wait, did you start these programs in high school?
I did. I had an engineering teacher in my first year in high school that was really supportive of other education and learning as many different technical skills as I could. So I started there and it was a great experience.
Hey, I'm Liam.
Hi, nice to meet you, Liam. I'm Lily.
Nice to meet you.
I'm Kaiser, nice to meet you, Liam.
You're students here at Davis Technical College. What is your guys' favorite part about working here?
Just seeing basically how they make a lot of strong parts in the aerospace industry.
What about you?
I'd have to say the completion of the products always, it's just very fulfilling.
So why did you guys choose this program?
Because I got interested in aerospace engineering and that brought up the composites part of it.
I got into it because of the job opportunity I was offered. Really good money. The more you get into it, the more entertaining working with composite pieces are.
When you see airplanes, race cars, or even high-end bicycles, there's a good chance they're made with composites similar to the ones made here at Davis Tech. They're incredibly strong and super lightweight, which is why so many industries want to use them. Finally, we are visiting the Automation and Control program, where we will get to see some really interesting machines, like a pie dispenser. Hey guys, I'm Liam.
I'm Tara.
Nice to meet you.
Hi, I'm Tara.
Nice to meet you. Nice to meet you guys. So some questions for you. What career can you get with automation and robotics?
You can get lots of different careers in automation and robotics. For example, you can be an automation technician where you can go through and integrate robots into the systems, make sure everything's running smoothly. You can be a maintenance worker and essentially just work on machines and make sure they're kept up to date and working properly. And then there's also a robotics operator who goes through, maintains the robots and anything else that they work with.
What has been your favorite thing about being here at Davis Tech?
Just kind of the creativity to mess around with things, play with them, and really see how things work.
I would say the same thing, to be able to get into the guts of these machines and stuff like that and see how they work and why they work.
So this is a PLC, this is the Allen Bradley, and this is the program I got, which is a ladder logic program. It's a traffic light simulation. And so it'll switch between your lights, and then if you want to go ahead and click that green button right there, it'll even do a little crosswalk section where it tells you to wait, and then it can tell you to walk. And then it will start up the traffic light again.
Oh wow. So how does this pumpkin pie machine work?
There is this conveyor belt, and over here, in here are these two sensor relays. Well, let's pretend this is our pie. When you send it down the line, it should trip these relays, and the cylinders in the back, you'll hear the pneumatic systems work. And if it was in use, pie would be deposited into the container.
Oh wow. The automation lab was amazing because students were actually designing and programming their own machines. They use technology to build mechanical systems that can solve real-world problems like crushing cans. They also learn how machines communicate, how production systems run automatically, and how robots can perform complex tasks. That brings us to the end of the video. Today at Davis Technical College, I saw how students can turn their interest in STEM into real careers. From welding and machining to composites and automation, these programs give students hands-on experience that industries really need. These students aren't just studying STEM, they're building things, programming machines, and creating real products. If you enjoyed anything in this video, consider signing up for a program at Davis Technical College, where they are helping train the next generation of skilled innovators. Be sure to subscribe to our YouTube channel to watch other videos like this one. See you later, STEM heads!